What is an invertible function? A function is said to be an invertible function if its inverse does exist. Now we will discuss how to check whether a given function is invertible or not. Let fx is equal to x plus 4 upon x minus 3, and f is defined from r minus curly bracket 3 to r minus curly bracket 1. That is, domain of the function is set of all the real numbers except 3, and codomain of the function is set of real numbers except 1. And fx is defined as x plus 4 upon x plus x minus 3, and we need to check whether this function is invertible or not. So if we need to check invertibility of a function, we should check its bijectivity, and if the function is a bijective function, that is, if a function is 1 onto function, then it must be invertible. So let us check injectivity of the function, whether the function is 1 or many 1. So criteria for that, we have to assume two arbitrary elements x1 and x2 from the domain such that fx1 is equal to fx2. Now fx1 is obtained by replacing x by x1 in the function, so we have x1 plus 4 upon x1 minus 3 is equal to, and fx2 is obtained by replacing x by x2 in the function, so we have x2 plus 4 upon x2 minus 3. x1 plus 4 is multiplied by x2 minus 3. If we transpose this term, it will multiply x plus x1 plus 4. And if we transpose x1 minus 3 to right hand side, it will multiply x2 plus 4. So that is equal to x1 minus 3 multiplied by x2 plus 4. Now proceeding from this step, multiply these two brackets together, x1 into x2, x1 into minus 3x1. Then 4 into x2, we get 4x2. And 4 into minus 3 minus 12 is equal to, now multiply these two, x1 into x2, x1, x2. Then x1 into 4x1, then minus 3 into x2, minus 3x2, and minus 3 into 4, minus 12. So obviously minus 12 from left hand side will cancel minus 12 from the right hand side, and x1, x2 from left hand side will cancel x1, x2 from the right hand side. Now transposing 4x1 to left hand side, we have minus 4x1, and minus 3x1 was already on left hand side, so minus 3x1 is equal to, now transpose this 4x2 to right hand side, so it becomes minus 4x2, and minus 3x2 was already there, minus 3x2. Now simplifying, we get minus 7x1 is equal to minus 7x2. Cancelling minus 7 from left hand side and right hand side, we get x1 is equal to x2. fx1 is equal to fx2 implies that x1 is equal to x2. So taking fx1 is equal to x2, if we get only one result, that is x1 is equal to x2, then the function must be 1 function. Thus, the criteria of 1 function is satisfied. We may say that f is 1 function. Now we have to check subjectivity of the function. For checking subjectivity of a function, we need to find its range. So fx is equal to x plus 4 upon x minus 3. So for finding range of the function, the steps are, first we take y is equal to fx, let y is equal to fx, then we write the value of fx over there, y is equal to x plus 4 upon x minus 3. Then we transform this expression, this equation, as x is a function of y, and in order to do so, we have to transpose x minus 3 to left hand side first. So we get y into x minus 3 is equal to x plus 4. Now opening the bracket, y will multiply both the terms. We have xy minus 3y is equal to x plus 4. Then we transpose this x to left hand side, xy minus x we get, and transpose 3y to right hand side, so we have 3y positive plus 4. Now taking x common out of these two terms, we have x bracket y minus 1, that is equal to 3y plus 4. Now transposing y minus 1 to right hand side, we have x is equal to 3y plus 4 upon y minus 1. So we have transformed our equation from y is a function of x into x is a function of y. And we observe for what values of y x is defined. So obviously x is defined for all the real values of y except y is equal to 1, because at y is equal to 1, denominator of this expression becomes 0. So x is defined for all y belongs to R, except, thus range of the function is equal to R minus curly bracket 1, that is all the real values except 1. F was defined from R minus curly bracket 3 to R minus curly bracket 1. So that means the codomain of the function is also R minus curly bracket 1. So we observed that the range of the function is exactly the same as codomain of the function, since range of f is exactly equal to codomain of f. Therefore, f is an onto function. So f is a bijective function, that is 1 onto function, and hence f is invertible. So this is the way to check invertibility of a function. Now how to find inverse of a function? Let fx is equal to x plus 4 upon x minus 3. We are taking the same function on which we have discussed how to find invertibility of the function, where f is defined from r minus curly bracket 3 to r minus curly bracket 1. So step 1, first we write y is equal to fx, that is y is equal to x plus 4 upon x minus 3. Then step 2, then we transform this equation as x is equal to a function of y, as we have done in the case of checking invertibility. So y x minus 3 is equal to x plus 4, or yx minus 3y is equal to x plus 4, or transposing x to this side and 3y to that side, we have yx minus x is equal to 3y plus 4. Then taking x common out of these two, we have y minus 1 into x is equal to 3y plus 4. Now transposing y minus 2 right hand side, finally we have x is equal to 3y plus 4 upon y minus 1. So we have changed y is a function of x form into x is equal to a function of y. So now step 3. In step 3, replace x by f inverse x and y by x. So we get f inverse x is equal to 3x plus 4 upon x minus 1. So this is the required inverse of the given function x plus 4 upon x minus 3. So if fx is equal to x plus 4 upon x minus 3, its inverse is 3x plus 4 upon x minus 1.